Okay, great. Well, welcome, welcome, welcome. It is 7 o'clock at night where I am. I am in Louisiana. Moved here about a year ago to be close to family, and I'm about 30 minutes east of New Orleans. If you're at all familiar with the geography of southern Louisiana, we are at the northeast end of that huge lake, Lake Pontchartrain, that's right above New Orleans. So it's about 9 million degrees here right now, but I've got air conditioning. All right, good. So we are going to do some Python coding tonight. So let's go ahead and get started. This is me when I had a little bit less gray in my hair. I guess I could update the picture, but hey, it's nice to live in the past. My name is Erik Gross. I've been a software developer for decades, and I have a Navy career. I operated nuclear reactors and did electronics technician work in the Navy, and that's where I discovered learning, education. I'd never done any training of anybody before then. It was wonderful, right? And I'm the co-founder of the Tech Academy. More about that in a little bit. Basic guidelines for the class. We have a class assistant. Christine is there to monitor the chat, answer questions, make sure that you're all nice. If you're not nice, she'll just boot you, but that doesn't really ever happen. I do want to stress that while we've made this a very entry-level, learn to code kind of class, and it really is, you will run into challenges. And part of the learning process is working through those challenges. So just expect to work a little hard and learn things, but use chat as needed. I definitely monitor chat all the way throughout the class. So that's Christine. Like we want to help people get through stuff. So another key point, and just keep this in mind when we get to actually writing code in a few minutes. Please be sure to type code that I write exactly as written. For a lot of reasons, a misspelled word or missing symbol, or even like something capitalized that shouldn't be capitalized, can result in errors in your computer program, right? So just type it out exactly as you can. I don't think we have anybody joining from a mobile device. If you do join from a mobile device, you can't really do the coding. It doesn't work that well at all. But please do stick around because you're going to learn a lot, even if you can't do the coding. Another key thing I want to cover, try to put yourself in a distraction-free environment so you can focus on the class and I don't lose you. Finally, if you fall behind in terms of writing all the code, don't worry about it. Don't get all stressed out. Just listen and learn. You still will learn a lot if you don't end up writing all the code. Often people ask whether this is being recorded, and of course you heard the message probably when you logged into the meeting. It is being recorded, and we do upload those videos, the recordings, into our free YouTube channel. We'll get you links for that. Also, we're going to be looking at a specific game. You're going to get the full code to that game at the end of the class. So you'll be able to play the game, tweak it to your heart's content, and have a lot of fun with it. And we're going to give you links to, like I said, the free YouTube videos and a bunch of other resources at the end of the event. Also, there's a really cool free gift at the end of the event. All right. Now, I think I already did this in terms of seeing where everybody's joining from. And so it's obvious people can use chat. And again, I am watching it all the time right now. Okay. Here's the basic agenda. We'll have a short explanation of the Tech Academy, who we are, what we're all about. And then we're going to write some code. Get your hands dirty. It's a lot of fun. I do try to do some Q&A while we're going through the coding. But if the time permitting, we'll have a brief Q&A session after the coding, and then we'll go over some information about our boot camps, how we deliver what we do to help people break into technology, because it's pretty cool. And like I said, there's a free gift at the end of the class. Stick around. Whole class should take about an hour to an hour and a half. All right. Who is the Tech Academy? What are we all about? Well, we do a lot of technology training, but the primary thing we deliver is what are called boot camps. Give me a 1 in chat if you're familiar with what a coding boot camp is. Drop a 1 in chat if you're familiar with what a coding boot camp is. And give me a 2 if you're not quite sure. A lot of 1s, a couple 2s. Excellent. Okay, good, even more 2s. All right, so we didn't invent coding boot camps, although we have been around pretty much since the beginning of the industry. About 11 to 12 years ago, in the San Francisco Bay Area, actually, coding boot camps came about. And what they are is intensive technology certification programs that are designed to prepare people for entry-level technology positions, i.e., learn to code in a matter of months. Now, we do a lot more than just coding, as you're going to see in a minute. But boot camps typically last between 3 and 6 months, depending upon what boot camp it is. And the key thing is they focus on modern practical skills. Now, we've been offering really thorough, budget-friendly, flexible, trusted coding boot camps for over a decade now. We were, in fact, around the very beginning of this industry, right? Our certification programs are cost-effective. They're self-paced, fully online coding boot camps, and they're tailored for beginners, people that have no prior technical or coding knowledge. And in fact, this class tonight you'll see an example of how we teach people that don't have any prior technical or coding knowledge. The programs we have cover in-demand skills that the tech industry wants. They're endorsed by stellar online reviews. They're designed to fit around your personal schedule. We've got really flexible scheduling, and we want to prepare you for your technology career with a really well-rounded toolkit of skills. In America, the average price of boot camps is around $13,500. Ours are under the national average. In fact, we have boot camps that start at $5,980, like under $6K, to be able to break into technology, which is pretty cool. The last thing I'll say on this specific slide is that I want to read our mission statement, why we're here, why we're doing what we're doing. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. We like to say that our product is you working in tech. All right, now let's get into some training here. We're going to cover a few basic definitions and concepts before we get into coding. One of the big things that we've learned over the years is that if you just throw someone into coding, writing programs, without enough background, it can be very overwhelming. So a couple basic terms and concepts. The first one is, what's a program? Well, this is a series of instructions, written instructions that you can enter into a computer and they make it do things. At its core, that's all a program is you are directing the computer to do specific tasks. And we do that using programming languages. They're systems of words and symbols and phrases, and they allow you to communicate with the computer and tell it what to do. Programming languages are what we use to make programs. So let's look at the verb coding. It's an action of entering those types of instructions into a computer. It's the action of creating that program. That's what coding is. Code is the instructions themselves. You could say, look at the code on the screen, and you'd be looking at instructions. So those are some basic terms. Now let's get to Python, because the specific programming language that you're going to get a taste of tonight is called Python. It's a really popular computer programming language, arguably the most popular in the world, right? JavaScript runs a close second, and they're neck and neck. But it's a really popular language for a lot of reasons. It's been around for a long time, about 35 years. And a couple key things about it. The language resembles common English words and speech, so it makes it pretty easy to understand what the code is doing, which is a nice feature. Not all programming languages are like that. And the other thing is, it was designed to be very versatile. It's not designed to make one specific type of program. You can use it to make lots of different things, creating applications, websites, games, and a whole lot more. So that's an overview of Python. All right, now, this next concept is one of the key things that we go into in our boot camp. There's a lot more that we go into in our boot camps, but this is a really key thing. And what we're gonna cover here is, no matter what the computer program is, what are the 5 basic elements that any computer program is made up of? Most computer programs have to have all of these to really be valuable, to really be effective. And so it really helps to understand what these 5 things are, and none of them are super complicated. So let's take a look. The first thing that a computer program has to have is an entrance point. It has to have the first instruction. In other words, when you tell the computer, start this program, what's the first thing the program does? Now, that probably kind of makes sense to you. It has to do something right at the beginning, right? Why is that valuable? Well, I'll give you an example why it's helpful to note that this is true about programs. Let's say, you actually do break into tech and you've got that, first developer position, and you go onto a team, and that team is responsible for maintaining a really large computer program. that's been around for a long time. This is pretty common, by the way. One of the first things you're going to want to do is get familiar with that program and what it does, but especially all those instructions inside it. Not just using the program, but you want to go behind the scenes and look at all the instructions, look at all the code. Well, if you know that there is a first instruction somewhere in that program, and you identify where that instruction is, it's the best place for you to start stepping through the instructions to fully understand what the computer program is all about. I'm sure you can see that if you just picked somewhere at random halfway through a program and tried to step through and figure out what all these instructions were all about, you're lacking so much context. So just knowing that there's an entrance point can be really valuable. So that's the first thing a program has to have, an entrance point. Second thing a program has to have, and by the way, these are not in the order you would put them in a program necessarily. These are just things that are in a program. The second thing is what we call variables. And you see what it says on the screen there. Variables are pieces of data that a computer program uses where the data can change. This is really valuable. If you've got a game and your score is going to change as you're playing it, you need to be able to keep track of that data, that score that changes. You'll use a thing called a variable to keep track of data like that. And you're going to do this all tonight, okay? The next element of a computer program that makes it really valuable is what we call control and branching. These are decision points in a program. Very often you need your program to be able to look at data and based on the data, decide upon doing one of two or more different actions, two or more different steps, right? And they call those two or more possible actions, they call them branches. So we have control, take a look at data and figure out what to do. And branches, go down one of those particular sets of instructions based on what the data was. And again, you're going to build one of these tonight and it should become pretty crystal clear to you. But a program has to have these. Programs have to have the ability to make decisions based on the condition of data. All right. Another really huge element of any computer program is what we call subprograms. Again, it says it right there on the screen, programs within programs. Here's what this means. You can have inside of your program a set of instructions that get used over and over and over again. Now, without a subprogram, you would have to type out those exact instructions in their exact correct order every single time you needed that series of steps to happen in your program. Think about, creating the window that goes, we've all used Windows on all operating systems. We're all used to having windows that open up and they have some sort of a mechanism to make them large or resize them or close them or whatever, right? How many times in a program are you going to pop up a window? Well, probably a lot. You're not going to want to have to rewrite those instructions every single time. So what you can do is take the instructions that do a common activity in your program, take those instructions and put them into a little box called a subprogram and give that box a name. And then every time you need that series of instructions to happen, you just call on that box and say, hey, do the instructions inside there. Again, you'll build one of these tonight, so you'll see it in action. But if you don't have these in your computer program, it makes it really hard to build and maintain a program. The final element of these 5 elements of a program is what's called an exit point. There needs to be a final step that tells the computer, hey, this program is closing. Now, why is that important? Well, here's one of the biggest reasons why. When you start a computer program, the computer that it's on does several really important things. And one of the biggest, most important things the computer does is it says, all right, I've just started a program, like say Microsoft Word. Just started this program. Now, inside the computer, I'm going to tap, that's my desktop right next to me, right? Inside that computer are physical devices, little teeny physical components called memory. And this is where you store data. Now, your program needs to have some of that available storage area all to itself while it's running. You don't want to have any chance that another program in your computer can get into that area where the data is stored and mess up the data your program is relying on. And it's your computer, your operating system like Windows or Mac OS or Linux, whatever. It's your operating system that does all that for you. It reserves a big chunk of that available, storage space to put data and says, this space belongs to program blank. Well, that's great. But when the program's done, you need a way to tell the operating system, tell the computer, hey, we're not using this program anymore. It's turned off. You don't have to keep that storage area reserved anymore, which frees it up for another program to use it. There's other things that happen, and you'll learn all about them on the bootcamp, but that's one of the biggest ones. So take a look at these 5 elements. These elements are the only thing you will ever find inside any computer program. Yeah, a computer program can be pretty complex, but at its core, it's only ever made up of combinations of these 5 things. And 2 of them are pretty rigid. There's an entrance and an exit. So it really means the things you need to get comfortable with, for the most part, in learning a new programming language are variables, control and branching statements, and subprograms. So we're going to learn all of these. You're going to get your hands dirty with them, but I want to present you with this 5 elements of a computer program, and then we can start to code. Now, if you're going to write code instructions, you need a place to enter them. So in a moment here, you're all going to get access to a code editor. This is a window where you can type in the instructions of your program and then run them, execute the instructions. So if I could have my assistant drop a link to the code editor into chat. There it is, right? I want everybody to click on that link. It says bit.ly Tech Academy Python. And when you click on it, you should see something like what you see on the right-hand side here. You'll see a browser tab open that has 2 little sections. On the left is a code section, and the right is like a blank space. That's your code editor, and we'll get into how to use it in a moment. But here's the next most important thing. You're going to be working in your code editor, but I see my code editor at the same time. So what I want you to do right now is set up, if you have 2 monitors, just put your code editor on one of them and Zoom on the other. That's nice and easy. But if you only got 1 monitor, then I want them side by side. So put the Zoom, which is going to be me, on the left-hand side, and put your new code editor you have on the right-hand side. Here's some hints on that, because sometimes it's not that easy to set it up. If you're having trouble resizing the Zoom window, you can click on these words that say Zoom meeting, and a restore button comes up. When you click on that, it'll make it really easy to resize your Zoom window and put it off to the left. Same thing with the browser. There's a little symbol on the top right here that looks like 2 windows. When you click on it, it lets you resize the browser a lot more easily. So I'm going to take a sip of water while everybody gets set up with Zoom on the left and your code editor on the right. Right, and I am going to open up my code editor, if you'll give me just a moment. All right, here's my code editor. Now, let me go ahead and make this a little bit larger. All right, I think everybody can see that. Give me a 1 in chat if you can read that easily. Give me a 2 if you cannot read it very easily. Got some 1s, got some 1s, got some 1s. All right, I got a 2, a bunch of 1s. Okay. I'm gonna try to, I'll do it 1. Let's see, make it 1 little bit larger. Let's see if that helps. Yeah, it takes away the window on the left, so, or on the right. So I'm gonna have to keep it like that. Okay. Now, all this code that's in here, you can select all of it and just delete it. Don't worry about any of that. Okay. Now, on the left is where you're going to enter your code instructions. And you'll see that we're, each line of code that we're going to enter has a number. Makes it nice and easy to talk about which instruction. Okay. So Let's get started writing some code. Here's the first thing we're going to do is we're just going to make it so that something appears on the screen on the right-hand side. We're going to print something to the screen. So Python has a bunch of built-in code instructions, and one of them is called print. Now, all in lowercase, I want you to type in print like that. Don't hit the space bar afterwards. And then I want you to do an open and closed parentheses. Now leave your cursor right inside the open and closed parentheses. Now, before we do anything else, let's just talk about this a little bit. We're going to cover actually a pretty important concept in Python and really in all of programming. This instruction that we're looking at, this instruction called print, the technical word for it is called a function. And it is a built-in feature or set of functionality inside Python. And the way it works is probably relatively intuitive. Inside these parentheses, you're going to put something that you'd like to print to the screen. So I want to do that, and then we'll talk a bit more about how this works. So what we're going to put to the screen is some text that says, hello world. This is very common. So give me double quotes, and then hello, comma, world with an exclamation point. And when you're done with that, go ahead and hit this button up here that's like a play button, and it'll run your code. And notice it says hello world on the right-hand side. So if that's not working for you, give me a 2 in chat if it's not working. All right. So again, let's talk about a couple concepts here. What goes inside the parentheses is information needed in order for the instruction to do its job. We have an instruction called print, and we immediately put some parentheses after it. And what's supposed to go inside there is information that without that information, this function print won't really be able to do its job. So we're passing it, we're giving it, the word is passing, we're giving information to this function so it can do its job. And you'll see this convention used over and over again. We'll come back to it later on when we create our own subprograms. But that's what you're looking at, is a built-in instruction inside of Python called print. And you just successfully entered an instruction in. It's obviously not the most complex program in the world. It's got one instruction, but it worked. All right, now let's go to the end of the line and hit enter. Now, you would only have to hit enter once and do another instruction. We could do it on this line 2, but just for readability's sake, I want to hit enter again and just have a little bit of separation. It makes it easier to read the code. It's not required. It just makes it easier to read. All right, let me take a sip of water. Now, we obviously have a first instruction. It's the instruction at the top. And now let's talk about that other one of the 5 fundamental elements, the variable. Let's say that we have a program that we're going to do, and we actually have a Hangman program. I'll show it to you here in a moment. We have a Hangman program that we're going to show you, and you'll be able to play with, and you'll understand pretty well by the end of this training. But we probably want to keep track of what's the name of the player. And this is common in a lot of games. I imagine most of you or all of you have played games where you enter in either your name or the name of the character you're playing, whatever. Let's say the player name is something we want to keep track of. And we want it to be something that can change. You can change your character name or your player name. So let's make a variable that's going to store the information of who the current player is. In Python, to make a variable, all you have to do is type out the name of the variable. So we have to come up with a name. This is going to be pretty easy. We're going to use player. So type P-L-A-Y-E-R. Make it all lowercase. You don't have to, but makes it standard, pretty common to use lowercase for variables. So here's the next really cool teaching moment. All we've done right now is created a variable called player. Let me explain a little bit about what happens inside the computer when we make this variable called player. I mentioned earlier that in the computer are these devices where you can store data. They're called memory storage or storage devices. You might have heard a term RAM. That means random access memory. And that is just what I said. It's a device where you can store data. Well, what we've done right now with my line 3 here, where we type the word player, we're creating a variable. What's specifically happening is a portion of the computer memory device has been reserved and it's ready to hold some data. More precisely, a specific location in that memory device has been given a name, and that name is player. Now, there's no data stored in that location yet. Here's the best way to think of it. Think of a bucket, like a pail that you would take to the beach or whatever, right? And on the outside of the bucket, we've got the name player. And it's meant to hold some information. Something's supposed to be inside the bucket. But we haven't put anything inside the bucket yet. So now we need to do that. So there's 2 terms I want to cover. Initializing a variable. The word is initialize. That's what we've done here. That just means creating the variable. And assigning a value to the variable. That's what we need to do next. We need to put some information in the bucket. In Python, you do that by clearly like writing the name of the variable. We've written the name player. Now hit space and the symbol equals and then space again. That equals symbol is an actual instruction to Python. And it tells Python, look at the variable to the left of you. In this case, the variable is player. And inside that variable, store the information to the right of you. We're about to put some information to the right of that symbol. So that's what that equal symbol means. It's called an assignment operator because we are assigning a value to the variable. So use your name, do double quotes, and then just put your name. Obviously, I'm putting Erik. And that is a complete instruction right there. And it does 2 things. It initializes or creates the variable called player, and then it assigns a value to that variable. Well, let's use that variable. Why don't we print it to the screen? Hit enter a couple more times. Use that instruction again of print and hit some parentheses. And instead of putting some text in there, you know, stuff inside of double quotes, instead of putting some text, let's just put the variable player like that. And go ahead and run it. And so you should get hello world and then your name. If you don't get that, give me a 2 in chat. Awesome. Now, again, I know these are very simple examples, but the fundamentals are here and are super important. In this case, here's what's at work. This built-in function, print, that's built into the Python language, inside the parentheses after the instruction, you can provide either some actual text, like we do right here on line 1, or you can provide a variable whose value is text. And that's what we have here. We have a variable called player that's been assigned a value that's some text. So we can use that with this built-in print function. And you're going to see that kind of a pattern quite often, where you're going to use an instruction, in this case, print. You're going to use an instruction, and you're going to give it information. That information is either going to be really straightforward information, or it's a variable that contains information. You'll see that pattern a lot in computer programming. All right. Now, we said that variables are keeping track of information that can change. Well, let's change the name of the player, shall we? Let's do player again. Let's do another assignment operator of an equals. Let's get a different name. I want everybody to give it the name Bob. We've changed the value in the variable. What's inside that bucket? You know, I used that silly example of a bucket. What's inside the bucket has changed. Well, are we sure? Go ahead and run your code. And it still says Erik. Anybody got an idea why it still says Erik? Drop in the chat why you think that we're still getting Eric, or it'll be your name. Why is it not putting out Bob? Absolutely. Swetha says we need to print. We're storing the first player value. Absolutely. At the time that we execute this print, the value of player is still Eric. We haven't changed it yet. So let's go and hit enter another couple of times, and we'll print the value of player again. And now it should do Eric, but then it should do Bob. So again, very simple example. We're just demonstrating that a variable holds data that can change. All right. Yeah, I've got a bunch of right answers on there. That's excellent. All right. Yeah, Linda, I think you're on the right track. We have, in fact, adjusted the name, but we never printed it. All right, good. Excellent. All right. Now let's talk about, excellent. Thank you, Linda. Let's talk about control and branching. Now, what I can do right now is I don't want anybody to switch. Don't get rid of your code, okay? I am going to get rid of my code because I'm going to show you all something really cool here in a moment, or for a moment. I need to find this code. Give me just a second. All right. Hangman. All right, I've got way too many Zoom windows all over the place. I apologize. Give me just a moment. Okay, now take a look at this. Don't try to type any of this. What this is the full code to a game of Hangman. Now you're going to get all of this, okay? Don't grab it right now. We haven't put the link in the chat yet. I'm going to copy all that code. I'm going to go back to my code editor. What I'm going to do is I'm going to put in this full program. I just pasted in all the code to a full program, and I'm going to play it. All right, so if you're not familiar with Hangman, I don't know what to say. You're trying to guess a word, and if you get the guess wrong, then we start building a body on a hangman's noose, and if they build the whole body, then he dies. It's a horribly negative game, but everybody knows it. So I'm going to guess a letter E. Ooh, E is not in the word. Ah, man, it put a head on there, on the body. How about A? Oh, there's an A. Okay, all right. I'm looking for other vowels. How about an I? There is an I, all right. How about a T? Nope. Oh, man, look at that. I got a torso. And then an S. S isn't in there. R. Oh, I got one. Okay. Let's see. What is that? A, E, I. O? Let's see, is there an O? No, I've already guessed it. Okay. All right, so you see the game. I'm not going to spend a bunch of time with it. You'll get a chance to play the game, okay? So here's the point is, if I go here and go back, let's go back to my code and run it to make things clean. We're trying to think of of a situation where we want to be able to have the computer make a decision. So one of the things is, how many turns does the person have? Let's say they have 10 tries to guess the word. And if they guess a word and it's not right, then we're going to add another turn on. And if they've reached the maximum number of turns, then the game's over. So what we want to do is write some code that determines whether or not the game is over. That's all. Is the game over? And the game is over if the number of turns reaches 10. That's all they get. Or actually, if it's reaches 11 because they get 10 turns. So if they reach 11 turns, sorry, game's over. Okay. Now let's build some code that will do that. First, we need a variable that will keep track of how many turns they've taken. So let's go to the bottom here and make a variable called turns, T-U-R-N-S. Let's assign it a value of, say, 4. They've only taken 4 turns, right? Now, this is where we learn about the control and branching element of a computer program. First, the control. How do you control whether the computer does one of 2 or more possible actions? You do it with specialized instructions built into Python called control instructions. And one of them is a really common instruction called if. So type if. Now this instruction needs some information to do its job. What it needs is it needs to look at data. More precisely, it needs to look at data about which it can make a decision. And that's very precise. Michael asks, why are there no quotes around 4? Because it's the type of data it is. This is not text data, this is number data. Text data will have the quotes around it, like Bob or Eric, and number data will not have quotes around it. Does that answer your question, Michael? Excellent. Good job. This is a good question. There are different types of data, which is something you learn all about the different data types and how to use them all inside of our boot camps. All right, no, back to this instruction that's called if. It's a control instruction, and we need to give it information about which it can make a decision. And here's the decision that we want to have it make. Is the number of turns more than 10? That's all we want to know. Is it more than 10 turns? Because if it is, sorry, game over. So let's immediately after the if, put some parentheses, and inside here, we're going to give it information about which it can make a decision. More precisely, we want to know whether or not the number of turns is greater than 10. So let's start this condition we're going to build. We're going to start it from the inside and then go out. We're going to build it from the inside out. So I want you to hit space once, and I want you to hit the greater than symbol. It's usually just to the left of the shift key, and it looks like that. And then hit space again. So let's talk about this. That symbol, the greater than, is a specific exact instruction to Python. And here's what it says. What it says is true or false. Is the item on the left of this symbol greater than the item on the right? Is that true or false? That's what it means. Give me a true or a false. So what do we want to compare? Well, we want to compare, go back to the beginning there, right after the parentheses, the value of the variable called turns. And we want to know, is it greater than 10? Now, I'm going to highlight this little chunk in here. That is a condition. It's either true or false. There's no ambiguity to it. And this gives us actually some really valuable insight into how computers work. Computers don't do ambiguity. They don't do maybe. They don't do sometimes. They don't do ish. They deal in yes or no, true or false, black and white, that's it. And that's what a condition is at its core, is there's no ambiguity. Either the value of the variable called turns is greater than 10 or it's not. There's no in between. So we now have this instruction, if it's a control instruction, and we've given it a condition which can be determined whether it's true or false. And now we need to start building, well, what are the things we do if it's true? And what are the things we do if it's false? Here's how you do that. Go to the very end of the line and give me a symbol that's a colon. Not a semicolon, but a colon. Now, and we'll talk about what this symbol does. It's really cool. Here's what this symbol does, and you can use it in a couple different places in Python. And there are similar symbols in other languages. What it says is this: immediately following this line of code, like right after it, the next line of code, we're going to put one or more instructions that are only going to be performed if the condition is true. And that section of instructions that are only going to be performed if the condition is true is called a code block. It's a block of code that's all united as one thing. Now, in Python, the way we designate the code that's inside the block we're about to create is it gets indented by a couple of spaces. So I want everybody to hit enter and watch what happens. Our friendly editor that we're using at this website automatically indented the cursor 2 spaces. Pardon me, 2 spaces. Now, you can move it back if you want to, okay? But it got indented 2 spaces. Now, what this means is if we have the colon right here, then every line of code immediately after this that's indented by 2 spaces is all part of the same block of code. And those instructions will only be performed if this condition is true. So, what do we want to do if the condition is true? What do we want to do if the number of turns is greater than 10? Well, the game's over. So, to make it simple, we're just going to print, in parentheses, sorry, you are out of turns. That's it. And that is our entire code block. We're only going to do one thing. Now, when you look at the real program, there's a bit more complexity there, but it's the same concept at work. All right, so that's only one code block. We've only accounted for one possible outcome. Because remember, we're doing a condition here that is either true or false. We've figured out what to do if it's true. What do we do if it's false? What do we do if number of turns is less than 10? Well, here's how you do that. Hit enter. And this next part, I can't stress enough how important this next thing is. For people that are learning Python, right at the beginning of the Python journey, messing this next part up can produce all sorts of confusion. Don't type anything, but just listen for a moment. The next instruction we want to use is what's called the else instruction. The else instruction is really valuable. You put it right after an if, and it lets you list out what to do if the condition is not true. That's pretty valuable, right? Well, if we were to type that else instruction right where the cursor is right now, we'd be in big trouble because we're indented by 2 spaces. We're about to add another line to the code block that comes right after the colon. We don't want that. We want this next instruction not to be in the code block. We want this next instruction not to be in the here's what you do only if the condition is true. So what do? Hit backspace and go back to the level of the if right here. And if you forget that when you're writing Python at the very beginning, it can be so confusing because it looks like you're writing the code correctly, but something's not working. All right, so now we can use that else instruction though. And we can put a colon after it. And we're about to create another code block. We're about to put down the instructions that'll only happen if this condition is false. So what do we want to do? Well, hit enter. And notice that our code editor helped us out by indenting by a couple spaces. And we want to print, you get another turn. Print, you get another turn. Now, this is very simplified. In the actual game, there's a little more logic to use, but we're just illustrating how do you build this control and branching thing. So I want everybody to put in the chat, what do you think is going to print out when we run this? Put in the chat, what's going to print out when we run this? You got another turn. Let's try it. Hey, look at that. Pardon me. Absolutely. Bunch of people got that right. Now, let's have a little fun here. And let's change this number of turns to 11. And let's run it again. It says, sorry, you're out of turns. Now, if your code is not working like this, give me a 2 in chat. If you're not getting the same results I am, give me a 2 in chat. All right, good. So we've covered a few of the really important things. We have one more really cool one to cover. What I'm going to do, go to the end here of the line, hit enter. Remember to go backspace because we're done with the control and branching. Oh, I want to explain one more thing. We call them control and branching instructions. The control instruction is the if or the else. That's a control instruction. The code blocks are the branches. A branch is one or more instructions that are only run based on a control instruction. So that's the branches. Think of it as like you're going up a tree and you can go off onto one branch or off onto another branch, right? Think of it as a fork in the road, whatever you want to do, okay? All right, so back to the bottom here. And remember, your cursor should be all the way to the left. It should not be indented by 2 spaces. And now we're going to talk about one of those final things, which is the idea of a sub-program. So let's just talk about this concept for a second. The thing we just did where we see whether or not the game is over, we're kind of going to have to do that over and over and over again, aren't we? Every single time a user makes a guess, we have to see whether or not the game's over. In other words, over and over again, we're going to have to see whether or not the number of turns is greater than 10. So I don't particularly want to have to type out this set of instructions 11 different times in my program. I'd rather not do that. I'd rather take these 4 lines of code right here, and I want to put them into a subprogram. And here's how you do it. You do it by creating what's called in Python a function. A function is the same concept as a subprogram that we talked about earlier in the training, right? When you want to make a subprogram, or again, we're going to call them functions. When you want to make a function in Python, use an instruction called def and hit a space. That means define. Define a function is what you're doing. What you are defining is a set of behavior that you can call on whenever you need it. And we need to give it a name. We're going to call this one game over, G-A-M-E, and then the underscore, that's like shift on the minus symbol, right? Underscore over, game over. That's the name of our function. Don't hit space after it, because we're about to talk about or reinforce another super important concept we talked about earlier. When you make a function, when you make this set of instructions that you can call on whenever you need it, you need to figure out whether or not that function needs information in order to do its job. So do a couple open and close parentheses right there. Right inside here is where you put information that the function will need to do its job, if it needs any information at all. Sometimes functions don't need information to do their job, but this one does. This function needs to know how many turns has the player used. So we're going to give it data, and we type it right inside here. We're going to give it this variable called turns. Go to the very end of that line and hit colon. Now, can anybody tell me what they think is going to go on the next line of code? Drop it in the chat. Yeah, Ariana, you were exactly right. Drop it in the chat if you think you know what's going to go on the next lines of code. Ooh, good. Yeah, Iqbal, Sweta, you're both correct, actually. Iqbal says the function code block. And then Sweta says if and else. You're both absolutely right. What's going to go after this is that block of code that you want to be performed when you ask for this function to do its job. When you ask for the function to do its job. Totally fine, Linda. That was awesome. All right, so it is a code block, and it's the code block that's quote unquote inside this function. So hit enter. Notice that our code editor, again, very friendly, automatically bumps over by two spaces. And what we want to put in here is the exact thing we did here. Every single time this function gets called, we want to run these 4 instructions. So you could copy and paste them if you want, or you can type them out again. I'm going to type them all out again. You guys can follow, copy and paste them if you want. It's if turns is greater than 10, colon, and then we're going to print, sorry, you are out of turns. And then we're going to do an else, and then we'll print, you get another turn. All right. Now I'm going to hit enter and then backspace a couple of times. Now I'm going to wait a moment for people to get caught up. Those of you who are copy and pasting, pay very close attention to your indentations. Pay close attention to how many spaces everything's indented over, and make sure it looks like my code. I say that because when you paste it, it ruins some of that. All right. In chat, give me a 1 when you're done building this code block right here. Give me a 1 when you're done. About halfway through. All right, we'll give it another 30 seconds. Ooh, Iqbal, that's excellent. Good job. I like your game over. Okay, good. All right, now, everybody take a look at my screen, and I want you to answer a question for me in chat. Don't run this right now yet. Don't run it yet if you haven't. How many times is the phrase, sorry, you are out of turns, how many times is that going to print on the screen when we run this? Put your guesses in the chat. How many times will that exact phrase be printed? Got a 1, 1, 1, 2. Got a 0, got a 1. Okay. Let's run it. And it runs it 1 time. Now let's talk about why. First of all, let's talk about the people who thought maybe it would happen 2 times. That's the most important thing here. We know that it's going to happen at least once because of this chunk of code right here. We're running this if, and we've got a condition in it. We check whether turns is greater than 10. Turns is 11, so it's clearly greater than 10. So we are going to print, sorry, you're out of turns. But why doesn't it print a second time down here? This next part is actually super important. And Hanani, if I pronounced your name incorrectly, I apologize, got the answer exactly. And so did Suprita. We didn't call the function yet. The best way to think of a function is it is potential behavior. It's behavior inside your program that you can use or cause to occur when you want it to. But all you're doing with this chunk of code is defining that potential behavior, defining the function. You have not yet requested that it actually be performed. And the action of requesting that it be performed, the term we use is calling the function. How do you call the function? We'll go down to the very bottom here. Again, make sure that you're backspaced all the way to the beginning of the line, right? Hit enter a couple times, give yourself some room. The way you call a function, the way you ask for its functionality, its instructions to be performed, is just by typing out its name and giving it any information if it needs it. So let's type out the name, game underscore over. And in here, let's say the person's only at 2 turns. So give it a 2. We're going to give information. We're going to say, hey, we're only at 2 turns. Is the game over yet? Run that. And now notice that the last thing it says is you get another turn. Why? Because we ran the function game over and we passed in the value 2. That means we called game over and gave it 2. We went to this line. Turns was equal to 2, which is not greater than 10. So we went down here and said, you get another turn. Let's do it again. Call game over. Game underscore over. And let's pass it 15. I don't know how they're going to get to 15, but let's say all of a sudden there are 15 turns. Run it. And it should definitely say, sorry, you're out of turns. Now, notice what's cool here. We get to execute these 4 instructions exactly as we want them over and over again with only 1 line of code. Now, let's say the designers of the game said, hey, you know that thing that that Iqbal did was really cool. He went, when someone is out of turns, we said game over at the end. Now, if we were putting this chunk of code repeated over and over throughout our program, this original one we did, where it is not inside a function, if we want to change the message, we have to change it every single place in the code we used it. Now all we have to do is go inside the function definition, go to the end of this line, and do period game over. If I need to make this a little wider so I can see what's going on. Like that. And now we changed the behavior throughout the entire program. We can change it in one place, which makes functions super valuable. All right. Now, I want to get you all the code. If my assistant drop the link to the code, this file, into chat. All right, let me grab it. All right, grab that link. You should get this code, copy all of it, like Control A, Control C. If you're on a Mac, it's Command A, Command C, of course. And then go back here, select all of your code and delete it, and then paste in this new code. And now I want you to spend a minute or so playing the game, okay? I'm going to play the game myself. Hit play. Let's play Hangman. I'm going to try again. Ooh, I'm almost dying. Oh, I got, okay. Oh, man, Rajani. Don't give me hints. Fine. All right. That was good. All right, I'll give it a second for anybody else who wants to keep playing. And then we're going to look at this code. Okay, good. All right, everybody pull your attention back to me for a moment. And I want to orient you to a couple of things inside this program. Now, we're not going to go through everything in this program in detail. That would be a much longer class. I will say that if you go through one of our boot camps, not only can you understand everything inside this program, but you can build programs like this on your own really easily and much more complex ones. But let's look at this program. First, I want to explain a new instruction in Python that you haven't seen. It's called import. Import is an instruction that says, hey, grab an exterior chunk of code built by somebody else, grab this exterior chunk of code called a library, and make it available for use inside my program. That's what import does. There are people that make pre-built, chunks of code. They call them libraries with a bunch of functions inside them that you can get for free, or sometimes you pay for them, but not very commonly. And we just want to use one of those in our program. So that's what import does. It says, grab this external library and make it available to my program. So that's what import is. Now, notice this is DEF. We know that one. That's define a function. So we define a function called choose word. Oh, look, you can see all the choices. There's coding. Okay. And then we use this library called random to choose one of those words randomly. Oh, awesome. That's a pretty cool function. Notice we don't need to give it any information in order for it to do its job. So the parentheses are there, but they're empty. All right, here's another function. Display hangman. Oh, look, tries. This is kind of like the turns thing that we talked about, right? So this is display hangman. You can see there's some sort of a variable called stages, and it's got these symbols on it that look like, in reverse order, a hangman character being created. If we go to the bottom of it, there's the noose with nothing. There's the noose with the head, noose with the torso, arms, other arms, leg, other leg. That's it. You're dead. Huh. Okay, good. That's that function. Oh, and here's another function. The function is called play, and it needs to take a word. We use a variable called word completion. We use a variable called guessed. We use a variable called guessed. Okay, you can start to read through this and figure out a little bit about how this program works. And now you have that code. It's yours. Mess around with it, have fun, make the list of words super long, and actually play hangman with a bunch of words, right? But you can see that that's what we do is we create a bunch of functions, and then right at the very bottom, we have a function called main. And here we call the function called main. Up until this point, our program hasn't done any work because we haven't called any functions. On line 128, we finally call a function. We call the main function. And when we run main, we run the function called choose word to get one of those words at random. And then we run the function called play, giving it the word that was chosen. And then we have a control statement, a control instruction. And then that means as long as someone chooses play again, then do it over again. Keep playing. So you can play infinitely if you keep saying yes. So that's the logic in here. And again, you could probably read through this and start to see some of how that works just based on what we learned tonight. All right, now let's go back to Q&A. Let me look at chat real quick. All right. Now, I tried to pick up some of the questions while we were going along. Does anybody have any questions that we didn't get to or they want to ask real quickly before we move on to the next step? All right, excellent. So I want you to stick around for the free gift. It is actually valuable. We'll send it to your house. It's really cool. Suprita, that is a good question, but that one takes about 10 minutes to explain. And so it's just beyond the scope of what we're going to do here, okay? Good question, okay? But if you will actually send that question in to me later we're going to give you an email address to get a hold of us. If you'll send that question in, I can send you back a detailed explanation of how that works, all right? 2 slashes on the first arm, but not the other. It's just how it worked to try to make a body, right? It looked vaguely real. I like that question, but how do you make it look? Because it's not a big graphics library. We're simply just using actual just characters on the keyboard to make it. So that's what we chose to make it look like. And you can tweak that. You can change that symbol because you now have the code. You can make them have 3 arms or 4 legs, so you get more turns. Okay, good. All right, so let's talk about the school here, okay? As you can see on the screen here, all these different symbols here, we've got a lot of boot camps. We actually have 12 online boot camps, and they cover this huge range of technology subjects, including artificial intelligence. That's a fun boot camp, let me tell you, and really, really valuable. Artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development, right? It covers all these, right? In fact, we have more certification programs than any other coding boot camp on earth because we want to give you the route into technology that makes sense for you. Now, a couple of points about how these boot camps are run. They're self-paced, but they're also instructor supported. They're flexible. Students can set their own study schedule, and you can enroll any day, 365 days a year. The content on them is really well-rounded and in-depth, and they're affordable. As I said earlier, they're priced under the national average, and we've got a really cool deal that I'll talk to you about in a moment. Another really neat aspect is that all of our programs include job placement training and assistance. It's one thing to learn how to code. It's another thing altogether to learn how to get hired in technology, and we cover both. But most importantly, these programs are designed for absolute beginners. No technology knowledge or experience is required, so you don't have to be a nerd to get through these programs. And who are these programs for? Anyone looking for a better career. Technology is a great industry to work in. There's remote work opportunities. It allows for a better work-life balance, and it pays well. We consistently land on every major best coding bootcamp list. Our average review rating across all major bootcamp review sites is 4.8 out of 5 stars, and that's based on student and graduate feedback. These are the people that have gone through the program have to say about us. We're really proud of that. So, why would you want to work in tech? Let me elaborate on that a little bit, okay? There are some myths about technology. And we've got a whole cool presentation tomorrow night about that as well. But here's a couple, just a short version of this. Technology does enable you to have a really good work-life balance. And increasingly, remote work is very real in this industry. It's changed a lot in the last few years, right? Also, it's a very creative industry. And you can take a lot of pride in the work that you do, a lot of personal pride. It's also a stable industry. I can get into a lot of nerdy details, but there's a talent shortage in this industry, more jobs than there are available personnel, and it's been that way for about 25 years and shows no signs of stopping. And it's an industry that pays well. And if you keep learning and working hard, there's regular increases in pay, and they can be quite sizable pay. That said, there are certain barriers to entry to doing a boot camp. Let's face it, anything that's going to be like 3, 4, 5, 6 months and helps you break into technology and get a really great job, there's going to be some barriers to that. One of the biggest ones is money. The tuition does cost thousands of dollars. It takes a lot to deliver a boot camp. Happen to know a lot about it, right? So what do we do to help try to handle that? One is we've got multiple financing options, including a really big one. There's a huge upfront discount if you can just pull the money together and just start the boot camp. More on that in a little bit. Also, we have monthly payment programs or options for people who have no credit, bad credit. There's lots of options. The point I want to make here, and look, this obviously I'm biased. I co-founded a boot camp. I care about boot camps a lot. But having now graduated thousands of people, I will say that I consider graduation from one of the boot camps here to be an investment in yourself. People go on to make 6 figures, very high 6 figures, steady income, really good work-life balance. It is an investment in yourself. You're giving yourself a set of valuable skills that the economy wants. Business wants these skills. All right, another barrier is time. There's a lot to learn in a short period of time. Now, some boot camps try to handle this by running what they call cohorts. If you're not familiar with the cohort system of training, it's where you can sign a bunch of people up, but they don't start yet. They all start on the same day. They are a group, a cohort. And that group cohort goes through the training material at the exact same pace, which means if you miss a day or a particular subject is harder for you and you get left behind, it's very hard to catch up. In addition, some boot camps actually demand, in-person training. Now, they've all got their reasons why, but one of the biggest reasons they're trying to handle the fact that there's a lot to get through and a shorter period of time to do it. We found that approach loses really valuable people. So our programs are fully online. You don't have to come into the campus. You can choose your own study schedule. Part-time study is allowed, and they're self-paced. What this means is you can study concurrently to holding down a job or even going to school. Finally, another barrier to doing a boot camp, you've got to have some technical interest or ability. But here's where there's one of the biggest confusions or myths about it. You don't have to know a whole lot. In other words, you may have tried to study technology and felt like, wow, this is beyond me. Maybe this kind of stuff isn't for me or whatever. Some of the materials may have seemed really difficult. That's because a lot of educators assume too much knowledge on the part of the new student. They assume you already know a bunch of things, and so they don't bother explaining them, and it makes it really difficult to understand. We don't do that. You don't have to be a nerd to get through our programs. You don't have to have any technical background to enroll. All right, so here's a question. And I don't need answers in the chat to this. It's just a personal question. Are you working like a dead-end job? And I don't mean that in a real mean or derogatory way. What I mean is, when you look at the job you're in or the industry you're in, how high is the income ceiling, even for top performers? Is it ever going to earn you what you'd really like to earn? That would be a dead-end job, because you're going to hit a ceiling and you know you want more than that. Maybe you've already hit that ceiling. Maybe you're even unemployed. Or is it really important to you to work from home or to have flexibility in that regard, to have more time you can spend with your loved ones, even though you're going to work really hard and do a good job, at your employment? The question is it time for a career change? It's a personal question. I can't answer it. But if it is, the Tech Academy is the solution. We're career change experts. This bridge in our symbol, the orange bridge, we chose it on purpose because we're trying to be a route into technology for everyone. Whatever confusions or, perceived barriers you have about technology, either using it or, better yet, working in tech, we can bridge that gap. And we now have over a decade of experience helping people break into tech. Another key fact, most of our Tech Academy grads make $30 an hour on average in their first job. Some more, some less, but now with over a decade, the numbers are very clear. That's $60,000 a year just to start for most graduates, right? And it's a big number. We've got over 1,000 graduates working in tech, and they work at any kind of company, from really small businesses, medium-sized businesses, to the really big giants like Facebook or Disney or Uber or Epic Games or Nike. We've got people at all of them, Salesforce, everything. So as a reminder, we have open enrollment, which means you can start anytime. If this is the right thing for you, you can enroll now, and I encourage you to do so. And here's how you do that. Oh, I forgot. Oh, this is cool. Okay, so we've been doing this we've trialed this, we've piloted this for a little bit, and it's been really successful. So we've decided to extend this next thing I'm going to show you into January. This is really cool. If you enroll in July, I said January, I can't speak. If you enroll like at the end of this month or in July, we have some amazing gifts for you. We've just tried this over the last few weeks, and it's worked really, really well. The first one is, if you can do the upfront payment, we'll give you a full 50% off the tuition. That, by the way, depending on the boot camp you choose, can save you anywhere between about $7,000 and $17,000. It's a really big discount. And by the way, you also get if you're in America and you need a laptop, we'll give you a refurbished laptop so you can do the program. That's for upfront payments. Now, the other cool thing, you're not going to have to pay sales tax. We'll pay it for you. No matter what state you're in, whatever's going on, we'll pay the sales tax. And we'll send you physical copies of all of our coding books, including an intro to coding book, which goes over a lot of the core concepts we covered tonight, but in a lot more detail. Our Computers and Technology Simplified book, which removes all sort of mystery from everything about computers and technology and the history of all the words are and everything. And speaking of words, we'll send you a copy of our Technology Basics Dictionary, which has thousands of simple, clear, easy to understand definitions for technical terms. It's very, very, very valuable. And we'll give you our career planning guide. Now, this took this is the culmination of about 25 years of work on the part of me and my co-founder. We consolidated everything we learned about how to navigate the first 3 years of your career all into one extremely comprehensive guide. What do you do? What do you concentrate on once you've gotten that first job for this first 6 months, for the first 18 months, for the first 36 months? Where should you put your attention to make sure you're setting a really solid foundation for a long-term career? And we've written all that up in this phenomenal career planning guide. And that's our gift to you if you enroll in July. Also, we have a phenomenal program called the Accelerator, which is the most access you can get to me possible. It's a career subscription. It's a simple subscription program with weekly workshops and access to about 100 free videos and classes, where you get in-depth, detailed, nerdy workshops with me, where we do deep dives into technology every single week. And you get 3 months of free access to that to really help accelerate your career. And finally, this is the biggest one. If you enroll right away or in July, you get unlimited job placement until you land your first job. Period. As long as you are still working and pushing to get that first job, we are there with you. You get access to all of our job placement materials. You get access to our job placement specialists, our alumni network. Everything we have, we bring to bear for you for as long as it takes. All right, Andrea, I'll answer that question in a moment. So, if this is of interest to you, then grab this link and drop it in the chat right here. Oh, it's right there. Awesome. Christine, you're great. Okay. So when you click on that, it'll take you a simple form to learn more. Okay. While people are doing that, I'll answer. So Manpreet, jobs can only be done if the person is present in USA. No, let me clarify what I meant about USA. Okay. In terms of doing the boot camp, you can do the boot camp from anywhere in the world. In terms of a refurbished laptop, if you do the full payment up front, we only do those for people in America. Now, I think what you might be asking about, though, is remote work. Remote work can be done from anywhere, right? And if you're talking about education, our program can be done from anywhere. So I hope that clarifies that. Manpreet, if I'm not answering your question, drop a clarification into chat, and I'll try to answer it better for you. By the way, when you click on this link and fill out the form, what it'll take you to next is a simple series of steps all about the Tech Academy. There's videos and articles that explain everything about who we are and how we work and how we teach and what the program's like, all the different boot camps. It's all in there for you to gather as much information as you need. Okay. Oh, Manpreet, yes. He asked, do we get unlimited job search assistant sitting in Canada also? Yes, absolutely. Wherever you are, we will help you with job search. We've gotten people hired all over. We have students from all over the world, right? And I don't know about Canadian. Yeah, no, wherever you are, we'll help you get a job where you are. And again, with remote work, you can work for anybody, which is pretty cool. I've worked for overseas companies. It works great, and vice versa. All right. Now, I want to mention our referral program. Since our graduates love us, referrals are one of the top enrollment sources for us and have been for many years. So we pay a 5% commission payment for all enrollments that come from referrals. So this isn't just for our graduates, though. If you have someone you think should be referred to this program, in a moment, I'll give you a way to do that. Tell them about us. Tell us about them. And if they end up, enrolling, we'll send you a check for 5% of their tuition. Period. No questions asked. It matters a lot to us. All right. I'm going to go briefly over this because I've already mentioned several of these. We have 7 publications. There are 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, the Technology Basics Dictionary I talked about, the Project Management Handbook, that tells you all about how to make software, and You Are Not Stupid, which is a phenomenal book that removes all that mystery from computers and technology. So, free gift. It is our free Introduction to Python book. It's a really good introduction to the entire language. There's a lot more in here about the 5 elements of any computer program, like much more, comprehensive. And the full explanation of the Python language and most of the instructions in it is all laid out. It's very practical. There's a lot of exercises. It's great. If you are in the US, we can send you a copy of this book right now. All you need to do is grab this email address, books@learncodinganywhere.com. Christine, can you put that into chat? There you go. Email us at that email address. Include your name and your full mailing address. Please include your address. Every once in a while, someone emails in and say, hey, can I get the book? But they don't give us an address to send it to. So give us your address. We'll send you a copy of the book. Also in this email, this is important. If there were questions I didn't get a chance to answer for you, include them in this email you send us. Those get forwarded to me, and I always reply. So I'll get back to you, okay? And if there's anybody you want to refer to us, put their name and contact information in there. We'll keep track of that. Grab a sip of water. So again, if you want a copy of our free book, the Python book, send us an email. Send us also in there any questions or any referrals. All right. I mentioned links, not just a link to this recording, but a bunch of links. If you go to our link tree, which is a nice service, you can see that in, let's see, Christine, can you drop link tree into the chat? Iqbal, we might be able to do that. I believe we can. Christine, can you take Iqbal's information down? Actually, Iqbal, email us in asking for a PDF version. Okay. I hope I pronounced your name right. All right. So back to this link tree thing. Okay. Christine, my assistant, just dropped in a link tree link. It says linktree/the Tech Academy. And if you go there, you will see all of our links. Look at that. There's a link to the most recent class, which is the one we're in right now. There's a link to our accelerator, the website, our boot camps, books and dictionary, all of our upcoming events right here, and free educational videos. That's our YouTube channel, where you'll find the recording that we're doing right now and all of our past free classes. You'll find all of that and a whole lot more there. So grab that link. And again, what's in here is, go back here. Let me get this. All right. So what's in there, like you saw a bunch of the stuff that's in there, including our social media accounts. So please follow us on social media. And if you want to get your own free copy of that You Are Not Stupid book, if you will tag us on social media with a link to the next class we have, we pick a person every single week at random who does that, and we give them a free copy of the book. All right. So again, thank you so much for attending. Really appreciate it. Hope it was helpful to you. If you filled out that form, and if you can put that link in again for anybody who still didn't get it, Christine, the link to the contact form, the /Erik. If you've filled that out, make sure you do the next steps. Watch those videos, read those articles, find everything out about the school and see whether or not it's a fit for you. You can even book a call with one of our admissions personnel. Linda, you're welcome. I hope this was helpful to you. I love all the questions as I was going through the training. You guys are great. And let's see you at the next event. We have a really special one tomorrow night. If you go to our meetup page, you'll see it. Thank you all. Have a really good evening.